Hi, I'm Liz Smith. I'm the event director with Expona, and I'm pleased to welcome you to this evening's webinar, our Electronics Designers Roundtable. Tonight we have about an hour. We're going to start with a panel discussion, and then we're going to take some questions from the audience, as many as we can. I know there's going to be a lot of questions, but we're probably only going to be able to get to a few, but we'll do our best. If you do have a question, please submit it via the Q&A feature at the bottom of your screen. It really helps us organize everyone's questions and see which ones are getting asked frequently so we can prioritize those. And feel free to use the chat for, talking amongst yourselves, but we're not going to be pulling questions from the chat. What else? We are recording tonight's webinar, so if you have, you're welcome to watch it again on the Expona YouTube channel. Okay, so tonight our panel will be moderated by Julie Mullins. Julie is a music-obsessed audio writer who is a managing and digital web editor with Absolute Sound and is currently a freelance contributing editor for Stereophile. Julie, thank you so much for being here tonight. Are you ready to get started?
Yes, my pleasure. Thanks for having me host or moderate, I guess. So yeah, I've got a lot of questions to get to and a great group. So let's see. Well, the theme tonight, well, first I'll introduce our panelists and then mention the theme. And we have a great mix of both tube and transistor specialists. So that's certainly of interest, and some who very much design both. We'll start with Kevin Hayes of Valve Amplification company, VAC, who designs quite glorious tube amplifiers and has pioneered a patented IQ auto biasing technology for the tubes that protects them, and they run quite seamlessly and things. So he founded VAC in 1990 and is based in Sarasota, Florida. And let's see, and also he mentions he has a lifelong passion for music and bringing recorded music back to life. And you can see some great stuff in the background there, the tape deck and so on. And we have Gordon Rankin of Wavelength Audio joining us. He's the president and chief scientist with that company, his own company. And he designs various tube amps as well as solid state, but specializes in SET amps and preamps, and also designs guitar amps. So crosses over into the pro side, and pedals as well for guitars. And DACs also. You may be familiar with the AudioQuest Dragonfly USB DACs. So those are his creations as well. And we have Dave Goodman joining us from Krell, longstanding heritage hi-fi company. He's been with the company since 1987. He's the director of product development, and he's also been engineering manager and staffer, and was behind the design of the K300i integrated in particular, among many other products, and also was behind the iBias technology that they feature. And last but not least, we have Nelson Pass, the DIY audio legend. He's published many of his schematics online, so he could be considered an open source designer of sorts. And let's see, and also, of course, is the designer behind Threshold, Pass Labs, and First Watt. So let's go ahead and get started. And the theme tonight, the first few questions, I've come up with a mix of questions, and also we did take some questions from registrants who registered for the webinar too. So we have a mix. Let's see, I'd like to start with each of you giving me your views on amplifier performance today versus 20 years ago, or even 30 or as long as 50 years ago, and how they sound similar or different to designs of today. And also if you want to mention how an amp sound relates to how it measures. Would anyone like to start? Who'd like to go first?
Well, if everyone's shy, I guess I'll go first.
That was a lot. You can take them one at a time.
I'll try to be brief too, because I only have so much information to impart. But I've heard amplifiers that have been built over a period of 70 to 80 years. And we've actually remanufactured amplifiers from the late 1950s and 1960s commercially for the Marantz company. And I think that the sound quality, the musical integrity of amplifiers is actually still increasing. And it's a little bit surprising to me because it's, whether it's tube or transistor, you're looking at relatively mature technologies. And if you look at the evolution of a technology, it follows what Richard Foster called an S-curve. If you look at performance on the vertical axis and a development time and money on the horizontal, all technologies start out very flat with a very small incline while they're trying to make them work at all. And then suddenly developments come fast and furious. You get a very strong rise. Then things tend to flatten out at the end. But in classical terms, they never totally flatten. There's always a small incremental amount of increase. But to my ear and to my judgment, the changes every 5 or 10 years are still significant. And I don't know that it relates so much to circuit topology as it does to understanding of implementations, grounding, more choices in terms of conductors and dielectrics, and just the process of applying the art with more insight than people were thinking about in the more fundamental days of breaking ground on the technologies. I think all of us, except maybe Nelson, get to do what we do because we're standing on the shoulders of some giants that came before us and worked out some of the most difficult portions. And what was the other question you asked?
Oh, the other, well, yes, really early designs like the Williamson, there are lots of foundational designs. Oh, wondering also how measurements might be applied or what they can tell you about an amplifier sound and how much you use measurements in your development.
Well, at VAC, I have a motto which says things must measure at least reasonably well and sound superb. If the measurements are bad, you have things that you can reasonably believe you can hear that are colorations or aberrations. Once you get measurements beyond a certain level of goodness, then it becomes the art of how things sound. And this is going to draw a certain amount of controversy from some people in the hobby, but we can find changing, say, take a standard mil-spec wire, a silver-plated Teflon coated wire, and say it's made by 3 different factories to the exact same specification. Belden makes it, Intec makes it, somebody else makes it. Each one of those spools of wire, those different wire manufacturing points, will give you a different sound with a wire made to the same spec. That's something that is difficult to measure. In some cases, we can't measure it. In some cases, we can get a little bit of an insight to it. But these are things which you can change in an amplifier's implementation, which affect the sound, but don't affect any of the generally accepted measurement parameters. This, again, is part of, I think, why one of the reasons we have improving sound is the wider range of materials available to us, not to diminish circuit changes. Most of the people on this panel, I think, have had contributions to the circuit art, but it's not just that, it's also, I think, the application of it.
I would, oh, sorry, are you?
Go right ahead.
I would agree with Kevin for the most part. And I would also say that designing amplifiers or electronics is definitely an evolutionary process. After each one that you design, you learn some things and then you think of new areas that you can try tweaking or making changes to on the next design. And invariably, it results in an improvement in the sound quality for the next generation of products. So I would agree with him that we're continuing to improve the sound quality. As far as measurements go, I would also agree for the most part, there are many things that affect the sounds that are not readily apparent in the measurements. However, there are some things that are very apparent in the measurements. One of the things that we've been discovering recently is just how different harmonic content of the distortion affects different parameters of the sound experience. So that's something that's definitely measurable on the test equipment. And depending on what part of the circuit you're playing with, you can adjust some of that as well.
Absolutely right. You know, I'll often quote the old Daniel von Recklinghausen statement that if it measures good and sounds bad, it is bad. If it measures bad and sounds good, you've measured the wrong thing. But while we have this sort of subjective side discussion, and I fully agree with what you said, I think it's important to note for those who are pure objectivists, I don't diminish the idea that one day we might have a group of measurements and tools that are good enough to actually be very predictive on sound quality. We just don't have that level of resolution and insight as yet, unfortunately. But things like Dave brought up, the harmonic content, the ratios, there are certain things that are naturally more musical to the human ear and other things that are not. And that was, I think, in the early days of the tube versus transistor argument, one of tube's advantages. The errors they tended to make when they were applied in a moderately good fashion were ones that were relatively musical. It doesn't mean you have to stay on those areas where you have a lot of second harmonic content or something of that nature. You can go low distortion and still have purity and good relationships among the harmonics that exist in the signal.
Yeah. Gordon or Nelson?
Well, I'm with both of you guys on that. And the thing is, of course, is that fundamentally we're in the entertainment business, which means that we have to basically try to develop a product that sounds appealing to a large or a reasonably large population of audiophiles who may or may not buy the products. And the diversity that you see in the customer base is pretty large. So it's actually pretty difficult to come up with a single standard for what constitutes good sound and expect that that's really going to stick. It's a big industry. It's my observation that if you can get 1% of the sales in the high-end market, you're doing actually quite well. And there's a fair amount of money associated with that. So you don't have to try to go and capture huge chunks of the market in high end. You can settle for a relatively narrow vision of what it is that you're doing and be quite successful. At least that's kind of my formula. And McLuhan put it very nicely. We take our, in this case, modified to say mature technologies, and we turn them into art. And much of what we're doing these days, I think, constitutes art. It's not a case where we are trying to adhere to the most finely tuned set of measurements that one can come up with, encompassing everything. It's even possible that a good chunk of the market does not respond to actual measured perfection. So that becomes a matter of taste. For example, has been close to my experience in the past 20. Out of my 50 years, maybe the last 20 has been playing with harmonic content and things that reflect in harmonic content or creative. And not only though, my personal insight, the one that has interested me the most is not so much that you have a distribution of, say, second and third and even higher order of harmonics in what you measure out of a sine wave, but when you start looking at the phase, the timing relationships of these things, you start actually being able to isolate effects that people fairly consistently respond to. And my favorite is simply that of the second harmonic. In a reasonable quantity, I mean, not into 0.0001% realm, but say at a 10th% or even higher, the phase of the harmonic can be what we refer to as either positive phase or negative phase in terms of its timing relationship. Positive phase means that the harmonic itself swings positive at both the positive and negative peaks of a fundamental. If it's negative, then it swings negative at those peaks, whether they're positive or negative of the fundamental. if it's positive, we get a consistent reaction from people who say, well, you know, it's let's say in both cases, they choose to complement the effect and be nice about it. If it's positive in phase, then it becomes a little more intimate. You could probably say it's a little more in your face, much of the presentation. And with negative phase, you start seeing people experiencing an expanded soundstage. The whole thing seems deeper. So you've got something that brings it more intimately in your face and something that moves it out. Now, I found that totally fascinating, and I have been exploiting it ever since. And it's one of those things that you can measure that I think a good chunk of the population will experience consistently. So it's a case where there is one of the areas where we do see a nice correlation between what people hear and something that you can easily measure. That said, it's not absolute, and I know people who, if you give them an opportunity to have it their way, will pick a third harmonic content amplifier, something which is dominant in third harmonic instead of this more favored or more popular declining of amplitude with the order of the harmonics. So that traditionally, the best tube equipment has tended to be a certain amount of second harmonic of modest proportion, and then declining as you go to third, and hopefully disappearing altogether in the fourth, fifth, and higher order harmonics. I've had product though that was purely third with almost no second and very little fourth, fifth, and sixth. And people experience that differently. They experience a set of dynamics associated with this. It actually appears, contrary to what you might expect, that when you see third harmonic compression in a waveform, it correlates to people thinking that the product is more dynamic. Totally not an expectation that I would have if you think about it, because compression shouldn't sound more dynamic because it's less dynamic. But there it is. So I think it's just fascinating to play with this, and I spend a lot of time doing just that. And since I build very simple Class A circuits, because that's what I favor, it's fun to screw around with these particular parameters and see not only what I think, because I'm not the only guy who counts in this endeavor, but what my customers think. And they're pretty free with their reaction, particularly the DIYers, which will tell you everything that you ever want to know about their experience. So I don't know. I think it's just fascinating. I'm not done, and I'm still having a lot of fun playing around with this stuff.
The learning curve goes on forever.
Yes.
Wonderful. Yeah.
Probably not. I'm 70 now.
I mean, the learning of the technology, it will outlive all of us. The phrase that you'll see people in process control, other endeavors will say is, the learning curve goes on forever. It flattens a lot, but still keeps going on. We keep learning something new every year, as Dave was saying. You learn something new from an experiment and you build on that. I think a little bit like you, Nelson, we make a deliberate, conscious effort once or twice a year to do development work around a part type or a circuit type we don't use, which we might not even think is a good idea in advance. And we'll spend 6 months or a year seeing what we can make out of it. And there have been 2 or 3 occasions over our 30-some years where we've really had the sound quality kick up a level of magnitude by doing something we never would have thought was a great idea. Aren't we? You can never let your theory tell you about the world. You have to let the world tell you about your theory.
Oh, that's interesting. And the experience of all that too over time. And well, that's something I certainly love about this hobby too, is that it's always evolving and there's always more to learn no matter what, no matter how deep your expertise in more and more areas. There's always more to learn and explore. So, Gordon, I'd like to hear from you. About your views on amplifier performance. You've obviously been doing this a long time as well. So.
Yeah, coming up on 40 years in November. So I think the biggest change that I've seen is passive components, capacitors, resistors. I think that's made a huge development in the quality of sound, at least in tube electronics. You know, it lowers the noise floor. You get better coupling, and sonically, I think we just have a lot more available to us to work with. And that's probably the big change. You know, I could probably take a Dynaco Stereo 70 and modify it with the same circuit with components from today, and I think it would sound significantly better. Yeah.
Or in some cases worse.
Yeah.
I've seen it go both ways.
It's been known to happen.
Yeah. Oh, great. Well, let's see.
I like screwing around with semiconductors.
That's the next, yeah. Well, let's see. Let's jump into the next question here. How would you say your design approaches or philosophies have evolved over time, over these decades? Or if, assuming they have, and if not, do they need to evolve?
Well, I'll start. You know, when I started Wavelength, I was actually buying tubes from Kevin, making push-pull amplifiers. And, you know, I was asked one day to make a single-ended amplifier. And I said, you know, nobody's going to buy a sub 20 watt amplifier. So I made this huge 845 amplifier, weighed 150 pounds. You know, it was behemoth. And I was like, oh, this sounds fantastic. So much better than push pull. I'm going this way. And I was at a tube swap meet locally in town. And Mike Marks said, oh, I have all these 45 tubes I just got from this guy. You should try these in an amplifier. And so I made an amplifier, and I think Corey Greenberg was writing for Stereophile at the time. And he used it to review the ProAct 100 studio monitors. And Atkinson went freaking nuts. He's like, we're not using a 2 watt amplifier to do this, but it sounded unbelievable. And at that point, I realized you can do so much with just a few watts. And I think Nelson can attest to this, you know, that you can really, if you concentrate on that first couple of watts, that you can do a lot with it with the right speakers and the right setup.
Yeah, I'm all with that. You know, we did for a Burning Amp Festival not last year, but the year before, something which was a headphone amplifier, just a little, real simple Class A amplifier that they could build themselves. And they did so on the first day of Burning Amp. A group of people got together and just cranked these out. And the amazing thing about it was only designed to do headphones. And it was only good for like maybe 2 watts, maybe more like a watt, really, when you look at a measurement standpoint. But we had the prototype here, and I had a nice, I no longer have them, but I had a nice big set of tannoy coaxials. And we went, oh, watch this, you know, just for the hell of it, hook these up to drive the tannoys. Well, it got levels that probably could get you tossed out of your apartment. And I was really astonished myself. But it reinforced to me that, you know, there's a lot to be had down at the lower levels. That said, I've got some other speakers here that you can toss a tonnage at it, and you know, and barely does the job. So, but I love the little amplifiers because first off, they're very everything comes down to.
Oh, Nelson, we lost just a bit there, the last sentence or two, I think.
Oh yeah, my internet
Connection.
It says right here that I'm unstable.
Is that the internet?
All newfangled technology. I mean, yeah, we're talking about tubes and it doesn't like it. No, let's see. But all right. Well, who would like to comment next on whether, how, and if your design philosophies or approaches have changed over time?
Well, I would say that my philosophy has not changed over time. I tend to approach the design from the point of trying to create the ideal voltage source, which is what the goal of the amplifier should be, theoretically. So for me, it's just a matter of technique to try to get there rather than changing the philosophy. And I would also say that I agree that those low wattages are definitely important, because with as little as maybe 1 to 10 watts, you can get an awful lot of sound. But if you make those early watts sound really good, people tend to want to turn it up more, and that's when you need the higher watts. So we've always designed higher power amplifiers because of that. And so the other advantage of having a lot of power is that at those lower wattages, you are barely taxing the amplifier, and you run more linear, lower distortion. And so those lower watts sound better even on a higher powered amplifier.
Nice.
Well, it's an interesting question, Julie. And I think Dave's teased around the edge of the point. Design philosophy has a lot of layers to it, I think. So, my goal has always been to try to bring music back to life from the records or other sources as much as possible. And that never changes. But when you start the engineering craft, you have what you might call your pet theories, your understanding of how the world works. In the 1980s, when I was coming into it, a lot of engineers, or at least people who wrote textbooks, worshipped at the altar of star grounds as the perfect grounding technique. Well, after you get a few years under your belt developing actual amplifiers and voicing them, you discover that's not necessarily the case. Now, is that a philosophy change? You could call star grounding a philosophy potentially, and then the moving to other variations of it or different types of grounding as being a change of philosophy. That learning continues. And as you go from design to design, as Dave said, you take with you what you've learned in the last one and you try to apply it. Often what you think you've learned from amplifier B translates to amplifier C. Sometimes it doesn't, which is interesting. Some techniques seem context dependent, and perhaps that context is not at that point in time fully understood by the designer. One of the phrases I often use, it's actually on the wall of our listening room at the factory, is, in a battle between theory and the real world will always win. So, we take our best understanding, we take our best shot, and then we listen honestly to what happens and alter it from there as necessary.
Great.
You want to listen to your customers as well. And I learned that because there have been things that, well, with First Watt, I could throw anything out the door that I feel like. It was because it was not really designed to be a big company or make a lot of money or anything else. It was just a place, but at the same time, importantly, send them out and see what happens. And I've had examples of things that I didn't like particularly. They had they were flawed in various ways. But you kick them out the door and people get back to you. And sometimes things that are I wouldn't have favored or have actually made a commitment to were loved. And they went, oh my God, this is absolutely great. And I'm going, well, this one over here, which is a very similar design, but it's got different parts. measures a lot better. And it's the same idea. It's the same topology. It's just that, oh, they didn't like that cheaper anyways, and became, a successful product. So one of the things I've learned not to do is to be the only judge of the product. And we try to float things past as many people as possible to get a sense of that, because people hear differently. And in my case, of course, I already know what's under the hood, and that influences my own thinking. I had, Dave remembers undoubtedly Joe Sammet, who was at Krell. I think yeah, I mean, let me say that Joe mentioned you many times. Just quick tale. Joe was a stockholder at ESS, right? Started in 19.
Oh gosh, we're having you fade in and out a little bit.
And then when threshold was terrible, it's a good story. Well, anyways, Joe had the kind of hearing where I could blind test him. Joe, I put 2 amplifiers in the back of your car, and I want you to come back and tell me. And they were identical looking. He didn't get to see them. He would put tape on it. One is A, the other is B. And I don't know, Dave, maybe you had this experience with him. Then he'd come back after a couple of weeks and go, this one is really quite good. This one over here, it needs a little help. Now, he heard better than I do. And in fact, I've learned to trust my own judgment and then go out and find out what people who hear better than me experience with stuff. And that's worked out really well. But what are you going to do? I try to correlate measurements that I have against what these people are telling me. And that's usually my guideline.
Nelson, you raise an interesting point. A number of times you said that people hear differently. And it's obviously true that ears are different, like hands are different, or eyes are different, and so forth. And there's the issue of taste. You take something that seems like a relatively simple single instrument, like an acoustic bass, and you can analyze, you have the pluck of the string, you have the vibration of the box, you have the column of air in it, you have the ring out and decay of the note. Well, to one person, that transient attack is the main thing for the bass. Somebody else, that's the tone and the ring out. So there can be different preferences, which I think become a bit wider in scope as people are further removed from the actual sound of acoustic instruments being played in their presence. A lot of people only hear music through PA systems or through solid-state amplifiers or Bose wave radios, and they get a notion that a bass sounds a certain way when in fact, in the real world, it doesn't. Must be about 10 years ago, 20 years ago, Sound and Vision magazine took a transistor amp and one of our tube amps and played it initially blind and then not blind for a band and its producer. And they would say that the transistor amp had a, I quoted, old-timey hi-fi sound, and the tube amplifier in the bass sounded like what they heard in the studio. Interesting. As designers, one of the most important things we can do, I think, is to actually be familiar with the sound of the instruments unaided to work from. But then beyond just the taste issue, the synergy issue, I think, raises its head. You can go to the Stereophile Class A recommended component list and assemble a system which just sounds terrible because the equipment doesn't complement the one piece to the other. They don't play well together. So, to put it on the most gross and exaggerated level, let's say someone has a speaker which is very bright, perhaps a small single diaphragm speaker, a point source type thing. An amplifier which produces a lot of excess second harmonic in the bottom end, psychoacoustically sounds richer and warmer. That might really be the best complement for their speaker. But it's a little bit like if you had a child piling up building blocks. You've got a block here, and then one goes that way. So the balance of the next block goes this way. And you build this S-shaped tower. It balanced, but it's not strong. It's not good. It's not, in some objective sense, quality. If you can put each block exactly on top of each other and build something which is straight and true and matches, as opposed to this warm component offsetting that bright component, I think you can get a little nearer to the true sound of whatever happened in the studio or on the mixing board or however that recording was done. What do you think?
Yeah, no, that's an interesting point. And actually that's a great segue into another question that came up regarding amplifier and speaker matching. And this was a question sourced from one of the registrants. But I'm sure a lot of listeners will have this question or some experience with this, with mixing and matching. I understand. Well, first, I guess all of you, I assume, test your amplifiers with a variety of speakers or of different types of parameters before they get released to market. The question that came in about amplifier speaker matching, matching impedances in particular of each. So the question is, what are the effects for both tube and transistor amplifiers driving a lower impedance speaker? And some speakers don't give their impedance values or their full impedance curve values in their specs. So can you speak about perhaps, speakers that also, that maybe nominally a 4 ohm load, but they have, there are points when it drops below to 3 ohms or 2 ohms. And this can put strain on an amplifier. So can you speak a little about that, about the effects for tube and transistors respectively, driving lower impedance speakers?
Well, that's one of the reasons why my philosophy of amplifier design is based on the ideal voltage source, because ideally it has 0 output impedance and infinite amount of current. And so therefore it would be independent of whatever the speaker load is doing. In reality, that doesn't happen because you can't achieve that ideal. But we found that if you can reduce the output impedance of the amplifier below a certain point, then it brings out a much more natural sound out of just about any speaker that you play it on.
Well, interestingly, I would agree with you, Dave. Absolutely, that having the output resistance of the amplifier be as low as possible, I would say in a static sense, is a good parameter. My experience, which I think differs from yours a bit, and that's fine, not saying right or wrong here, is that some of the steps taken in circuit design to lower the impedance beyond the natural point of the output devices or output transformers can have subjectively as much negative effect as positive effect. And at the end of the day, you also have to look at the total damping system in the equation. It's not just the resistance of the amplifier, but you have to add the speaker cables, the crossover components, the DCR of the speaker's voice coil itself. It was analyzed back in the 1960s, I think, by JBL, and they said effectively, you can never get a system damping factor beyond about 1.4, no matter what you do, with an infinitely zero output impedance amplifier. Then if you go to an amplifier with, say, only a 10 damping factor, you deteriorate it from 1.4 to 1.36 for the overall system. Speaking entirely in damping terms here, not in frequency response terms. So I don't tend to pursue heading toward that zero, that ideal voltage source in the work I do. Certainly you make some wonderful designs. So again, I'm not knocking what you do. We're just talking philosophies here. But at the end of the day, what I'm trying to get is the best apparent control of the speakers, of the music in the room, as opposed to the theory of a zero impedance amplifier will contain the best control of the speaker.
I definitely agree with you that the way that you achieve that low impedance makes a huge difference in the sound. I don't want to get into a big discussion about the merits of negative feedback, but it makes an enormous difference. And we've done some experiments in real time of adjusting various feedback parameters, and you can clearly hear the sound either warming up or hardening or becoming brittle. It's remarkable how much effect on the sound you can have by playing with that parameter.
Isn't it a wonderful avocation?
And you can measure this stuff. It's, you know, correlating it is another problem altogether, but you can see these things on your test equipment. I'm a big believer in measurements, even when I choose to ignore them.
Yeah, oh, good. Well, let's see. We do have another question here. This one will be a time challenge of sorts. Maybe this is one from another registered attendee. They're saying that they understand how to set up a basic amplification circuit in a tube amp, but how do you properly size an output transformer in 30 words or less? Just kidding, they said. So Gordon, is this something you'd like to tackle?
30 words or less. Okay, I'm already
30 seconds or less.
You're 1/3 of the way through, Gordon.
yeah.
30 seconds or less, no O's, ums.
I'll let Kevin do push-pull, but single-ended, you know, it's diminishing returns is really the big issue. If you want to get good low end, then you have to have a lot of inductance. That means a lot of turns of wire. And with a lot of turns of wire, you get capacitance, which kills the top end. So, you know, we work with those variables and, you know, years of experience to come up with an output transformer that matches the tube that we're working with.
Gordon's absolutely right, but I think it gets even deeper than that. We've sort of been talking a number of times along the way about audio engineering being sort of an art, a science, and a philosophy. And there is no blacker art than output transformer design that I know. It's not just how big is the core and how many turns. It's how the windings are sectioned, how they're interleaved, what is next to what in that core structure wound. At the simplest measurement level, what you're trying to do typically in a design is to get as much primary inductance as you can for low end, while minimizing stray capacitance and leakage inductance, which are your enemies at the high end. And depending upon the way you design the geometry of that transformer, that ratio can vary tremendously. I think some people refer to that as the quality factor of the transformer as a ratio. And I think the one thing I would suggest is you never really want your transformer to be the first thing that hits its headroom limit in an amplifier. Transformer limitation tends to have a dull and not so nice sound compared to having something else be the limiting factor at the highest end of power. I think we also forgot to answer part of the question you asked right before that, Julie, which is the impedance of the speaker and how you drive it. One thing that I've observed that generally is true, when you look at a speaker's impedance curve, there tends to be sort of a broad dip that happens somewhere in the base, 150, 100, 50, 40, somewhere down there. That sort of broad minimum. Matching that with a tube amp tends to me to be the point where the speaker sings the best. Now, there's something fundamentally very different about a transformer coupled amplifier, as most tube amplifiers are, and a non-transformer coupled amplifier, as most transistor amplifiers tend to be. Dave's point is low impedance, infinite power into decreasing impedances. There's an analogy that I use, and forgive me, it's not a fully accurate or persuasive analogy. Tube amplifiers work by trying to match their output devices to the load. That's what the transformer is doing, is positioning the load line to the tubes from the speaker's impedance. And so it's like you're a tennis player and you're trying to aim the ball at the sweet spot on your racket, thing with just the right amount of force. Transistor amplifiers are always running above their ideal match point in that theoretical sense. They're swinging harder and they're not aiming as carefully. That might not be a bad thing, don't get me wrong in that analogy, but a tube amplifier in almost all cases is designed to transfer its maximum power at some non-zero impedance. And in our case, often we find that delivering the maximum power into 2 or 4 ohms is the point where most modern audio speakers jump. In the case of the Krell, I imagine they really don't care either way. They're well above their match point, so they're comfortable regardless.
That's correct.
It's an interesting point, though. I mean, that, yeah, speaks to, I guess, just those different approaches. And that tied into another question I did skip over, but maybe I'll return to. But in the interest of time, Liz, we do want to save a little time for a few more brief, perhaps, incoming Q&A questions from those attending today's session. So what do you think, Liz? Should we jump into a couple of those, and then maybe I can return if people want to stick around to one other question?
Yeah, it looks like we've got a few incoming questions, so I think it'd be good. I think it's a good time to take a look at those.
Okay. All right, I'll do a tour and maybe come back to something slightly more, I don't want to say controversial, but negative feedback related, and one other item also. So one question, let's see, incoming. It seems that it's rare to see published how many watts are in Class A versus how many watts in Class B info on Class A, AB amps that are reviewed or information published in the specs. This information must be important to potential buyers. And why is it hard? Does it seem hard to come by? Is there a reason for that? Or can you say a little about that? So if it's Class A up X watt, and then Class A B.
A couple of things. First, as a term of the engineering art, you really don't have Class A watts up to a certain level, then Class B above. If an amplifier has a device hitting cutoff any point during its normal rated operation, it's an AB amplifier. It's not A below it, even though it's more properly termed no device in cutoff yet below that point. But in the hand waving sense, Class A up to a point is a statement that I think most people understand. One thing that happens is most devices, at least when you're working with relatively modest amounts of feedback, don't just suddenly cut off. It's not that suddenly your waveform does that. Typically, your waveform begins to just round a little bit more as you progressively go up in power level. There's an artistic call in terms of exactly where you would say it leaves Class A and goes to an AB operating point. Secondly, as a lover of music and a user of amplifiers, I really don't care. What matters to me is how the amplifier sounds. There are pure Class A amplifiers that don't sound good to me, and Class B amplifiers that sound better to me. I tend to like as much Class A as I can, given the way the devices, the output devices, in our case, the tube type wants to be used. In my experience, KT80 output tubes don't really want to be running pure Class A. They don't give their best sound that way. 300Bs love to be running Class A right up to the actual limit. So I would say it's more a case of listen to it and see if you like the way it sounds, as opposed to buying it based upon specs on paper.
Anyone else care to comment on Class AB?
I only make Class A amplifiers, so.
Right, I was going to say that makes sense, I guess, the SCTs.
Yep.
I would say the reason that most AB amplifiers aren't rated with their amount of bias is that an amp that is designed as a Class AB amplifier is designed that way in order to make it more efficient and to reduce the amount of heat that it would dissipate as compared to a pure Class A. So the amount of Class A bias that you have in that case is going to be very low. So I don't think most companies would want to advertise maybe 1 or 2 watts of Class A.
That would be a bad idea.
Yeah.
I think most of us who do AB designs don't only have 1 or 2 watts. That would be, you know, there actually are a couple of famous amplifier circuits in the tube world, at least, that are essentially pure Class B2 amplifiers. They're running 10 mils of standing idle current and power drive onto the grid to get where they're going. And one of those brands has been around for decades and is very well regarded. It's not my cup of tea, but it's been very successful.
Okay, well, I have another question. Oh, go ahead, Nelson. Did you?
I was just going to say, but it is a question that the customers are asking. And so it's become something that manufacturers are feeling compelled to reveal or otherwise, address. We give figures, but then we don't have too embarrassed because they're pretty high figures. And so some people can are a little more comfortable with it, but and it's really not correct for the consumer to try to make a judgment solely on that kind of a basis, in the same way that you wouldn't pull some single distortion spec out and say, see, here it is, and expect that is going to be the thing that makes the customer happy or not.
Amen.
I would agree with Nelson also that you could have an amplifier that only has a couple of watts of Class A power, and maybe that sounds better than one that's running 10 or 20 watts of Class A power. It's dependent on so many other variables.
One of the psychoacoustic factors, which also plays into the analog versus digital discussion, is the sensitivity of the human ear and brain to distortion. And as it happens, the human ear is most sensitive to distortion at very low amplitudes, very quiet signal levels. When things start getting to rock concert levels, it takes measurably a lot more distortion for a human being to say, oh, I hear distortion now. And so in that sense, if there's a bump in distortion that happens, say at 50 watts on a 100-watt amplifier, it may not have a practical consequence. It might, again, as you've pointed out very well, Nelson, the exact nature of the distortion, the phase of distortion, as Dave pointed out, the harmonic relationship of the distortion have an effect. But by and large, I think rich Class A B1 amplifiers can do very well just because of that phenomenon.
And we keep in mind that the human ear has considerable quantity of distortion when you get up to the louder levels. And
it's nonlinear by its nature.
It's going to swamp a lot of other effects.
Oh, that's an interesting point. Yeah. When you think of playing at concert levels or when distortion, might be more likely for changes to creep in. Yeah.
That's one of the fun things about the measurements versus subjective judgment too, is that our test instruments are linear devices. Our ears are not.
Yep.
Our brains are not either.
Correct.
And that's a very clear cut.
Yeah. And Gordon, you started to comment.
And instruments are not. So, the whole recording process is distorted in a way.
Yeah. And
especially electric guitar. I mean, that's all they go for, right?
that's true, the effects. And it's interesting on some old recordings, as an aside, you can hear flipping or, things with what was happening at that time, like old Muddy Waters or, in the studio, those effects. To hear that is exciting though. So, okay, let's just take a couple more here in the minutes we have left. Another question incoming. Do you think solid state versus tube amps favors digital versus analog input? What do you think about the mixing and matching of those?
There's one interesting thing I like about tubes in today's world. If you use a tube rectifier, it doesn't pass Wi-Fi and other BS that we have in our electrical system. It's just built to pass, 150 hertz, maybe 200 hertz, whatever, to make the high voltage that we require for our amplifiers. It does clean up the audio for a lot of things. And I think that's a big plus for digital music these days, is the ability for tubes to not pass that, anything over, let's say 40, 50K, whatever, it kind of actually acts as a filter.
It's an interesting point. I've often wondered if when we plug in, say, a 1954 Heathkit, whether we hear what it sounded like in 1954, because our power lines have so much more and different kinds of aberrations and pollution on them. In a sense, maybe it's not so much filtering out the unpleasantness, but not letting the pollution get into the audio system to begin with.
Yeah.
But in terms of source type, I view my job at VAC as making the best of any source that is presented to our product. I don't care if it's an MP3 file coming off a computer or a 78 RPM record or a master tape. The goal is to bring as much of what's there out in its proper, the elements in their proper relations to each other. And if you do that job right, I think the source becomes not really a main consideration. The source will have its own sound character, but the amplifier's job is to present whatever is there honestly and truthfully.
As a practical matter, these are the waters in which we swim. And so you just do your best with whatever source they're going to pick.
Yeah.
Interestingly, going back to something that Dave said earlier about very low impedance amplifiers being a standard, and I'm misquoting you, but a standard of perfection by which you can count in terms of eliciting the best response out of all speakers. There's only one problem with that. A lot of the guys designing speakers aren't necessarily using that as an amplifier in their testing. And so that's all over the map as well. And so, and yet they've made their aesthetic judgments based on something which is associated with an imperfect piece of auxiliary equipment, say an amplifier with a finite output impedance. You won't get exactly the same performance when you go to an amplifier that's perfect. And so you end up having to kind of pick your market and pick your customer a lot of the time. And that goes back to what I was saying earlier. It's a wide market. It's a big, wide market. If you can get a small percentage of the audiophiles to see it your way, you're a success. Mm-hmm. And so I've stopped worrying about all this quite so much.
That's a good point. Yeah. And I just, and Liz, I know we're getting to time now.
Yeah.
One other question, but I guess if there's anything else, or we could take one more.
You want to do one more question, I guess?
Let me take a look here. So maybe there could be, well, this may not be so simple or quick, but I guess somewhere I had asked earlier also whether monoblocks were preferable versus dual mono in a single chassis approaches. I know there are many variables obviously in play, not just in the circuitry, but the chassis itself. But is there an answer anyone would like to provide comment on?
I just prefer building them that way. It's easier for me not to electrocute myself.
They're easier to lift.
Yeah, easier to lift. Yep.
I think the difference there is very, very minor. We built a very popular amp years ago, which had 2 power cords coming in. It was dual mono, sharing a chassis. The only distinction between that and separate chassis monoblocks, I think, would be in whatever sort of stray couplings may exist between transformers or conductors. Those little bits of picofarads here and there, or a little bit of EMF here or there that bleeds from one channel to the other. But properly designed, that's a very minor and hopefully negligible factor.
I would agree with Kevin. I don't see a big practical difference between monoblocks and a dual mono design, except for some of those stray parasitic effects that you mentioned.
And I guess you can find ways to address those or work around them within that context of the particular design.
Yes.
Yeah.
Mm-hmm.
Okay.
When you get to the really powerful amplifiers or the class A's that are burning a lot of energy, monoblocks start making more sense because you can, a reasonable package can handle it.
Mhm.
and you don't want the guy having to, use a crane to put the thing into his living room. And yet, I can see stereo. I can imagine a 5-channel amplifier that would simply not be buildable under that scenario. Besides,
Nelson, I suddenly got
monoblocks are cool.
Yeah.
Yeah.
Nelson, I suddenly got a flashback to a couple of years ago when I saw one company bringing an engine hoist to bring their monoblocks into RMAF.
Well, that would be one of Dan's, wouldn't it? If
I don't think it was actually.
Oh, okay.
We
Might have been.
used to make an amp that required a crane. It's about 600 pounds.
Oh, wow. That's
Yeah.
like that's pretty wild there.
I
Ampzilla.
remember when Dan went through his bodybuilding phase, that maybe correlated to the development of that.
Makes you well-rounded, Dave.
I
Yeah.
was gonna say that'd be convenient. Oh gosh. Well, good.
Is
Thanks.
that-
I think.
Right.
All right. Well,
right,
anyone
Julie.
else? More comments? Oh, go ahead, Liz. I'm sorry.
No, I was just gonna say, is that like no more comments? Are we good? All right.
Yeah.
Okay, well, I guess then, we're right at a little after 6 o'clock. So I guess that's all the time we have for tonight. A huge thank you to Julie, Kevin, Dave, Nelson, and Gordon for taking the time to participate tonight and answer the questions and share your knowledge. It's really been such an honor for me, and I know everyone who's been watching. Thank you to everyone who joined our audience tonight. And we look forward to seeing everyone in person later this year at Expona. It's October 29th through 31st. So hopefully we'll see everyone there. Have a great night, everyone. Take care.
Thank you.
Thanks, everyone.